Morning, Chris.
Good morning. How's it going?
Yeah, not too bad. Yourself?
Yes, not too bad, thanks. Not too bad.
Good.
Just closing the window to deal with the digger that's around the corner. You know how it is.
Morning, gents.
Morning.
Well,
How we doing?
good, thank you.
Good. John, you're coming up as Michael Gilboy.
I'm it shows me as Sageza.
Nah, you're not. Sorry, Michael's underneath. Sorry. He's directly underneath you with his name. Let's do it.
Hello. Hi,
Morning.
everyone.
Morning.
You in the garden, Tim?
Yeah, my wife's into plants, so
Everybody hear me okay? Is my audio all right?
Yes, good morning.
Yes.
Cool. I had to come in the house because for some reason my monitor in the shed decided it wasn't going to work this morning. So
I thought you were in a different room to where I saw you previously.
no, I'm normally in the shed, which is much more effective for a tech talk because there's all sorts of technology lying around the place. You know, it's just bookcases.
Yeah.
So
Lawnmowers and trimmers and such like.
no, that's in the other shed.
This is his
And
tech,
of many sheds.
Yeah.
the tech safe haven, Chris, isn't it?
Absolutely.
So I think we'll give it a couple of minutes. Just
On
for
Sam.
Cool.
a few joiners.
Yeah.
You in the actual office there?
I am.
Nice.
Yeah, that would show a different side of loyalty if that was my living room wall.
Yeah, I am.
And the industrial looking ceiling tiles.
Yeah, I was going to say that that would be dedication. I'm going into our office this morning later on. Just feels a bit weird, doesn't it?
Yeah, I want to start coming in once a week, just for something different. I came in last week and it was strange missing the commute. Yeah. Martin, I've got there's a couple of people messaged to say that they're having trouble with the link.
One thing I noticed was when I clicked it on the meetup website, it kind of came up and said, "Do you want to continue?" But then wouldn't let me press the continue button. I ended up having to copy and paste the link into my browser.
That's what I ended up doing as well, actually, for
Yeah.
some reason.
Yes.
Do you want to just message them and suggest that, John? That would be handy.
Yeah, if you yeah, I've just responded to one person. It might be worth just emailing the wider group. Saying that though, we do have 18 people in, so
Yeah. Hold on. An email. Excuse me.
where is the office anyway, Chris? Is it city centre?
Yeah, we're in town. You know, Carlisle Square.
Yeah.
Just above the Repro shop there. So
Right, okay.
opposite the old Warwick Street bus station. So
Yeah.
which isn't there anymore, incidentally. It got demolished in the early part of this year. So was but yeah, it's a kind of it is actually quite convenient, although it's a sort of slightly out of the way part of town.
But city centre nonetheless.
But at least city centre, yes, easy enough. The problem with me of not having been in the office for the last year is mostly just not getting any exercise, because or at least having to do other exercise. I just cycle in, and it was just like, it was a nice way to start and finish the day. But
yeah, I didn't mind cycling in. It was just when you'd had an unexpected hectic day and it starts raining, you think, oh, I've got to cycle now.
Yeah.
Cool. Shall we get started then? I think
That's a good idea.
complete. Appreciate people have got day jobs as well after this.
Yeah, cool. I'm gonna start sharing on. So do you want to kick us off?
Yes, absolutely. So thanks for that, Chris. So yeah, welcome. Very warm welcome to today's event. It's the third event from We Are Tech. It's our first breakfast event, so it's good to see a good turn up, a few early birds in the membership, which is always nice. Obviously great to have Chris with us. But obviously, just before we go on to the main event, a few words from myself about the group and a quick agenda for the day. So yeah, obviously in terms of We Are Tech, for those of you that are new to the group, we're obviously a tech meetup group, and we really want to cover a broad range of topics, as you'll probably see from our previous and future events. It's quite diverse. We're based out of the northeast of England, but we're open to everyone, of course, regardless of location, especially as everything's currently online. Hopefully we'll be able to host a local event in person as well when it's safe to do so. So that's kind of at the back of our mind. Again, would love to have your input. So if you'd like to suggest a topic, please do so via the meetup page, or my email will appear at the end as well. And of course, we'll do our very best to facilitate that. Equally, if you want to speak or maybe know someone who does, feel free to let us know. I would say that the event's been recorded and added to our YouTube channel. So if you don't want to be visible, then I would say do switch your camera off. And a quick thanks as well to Sagiza, who are sponsoring the meetup this morning. Cool. Of the next slide, please, Chris. So yeah, the agenda very simply, obvious introductions done. Just in terms of the Q&A at the end, if you want to pop some comments in the box, that would be good, and we can kind of run through those after Chris has done his talk, which we're thinking about half an hour, 35 maybe 40 minutes, that will take. And then at the end, I'll kind of close proceedings, and we'll have an overview of our next event. So yeah, I suppose without further ado, Chris, it's over to yourself.
Thank you very much. That's a great introduction. So let's get started. Lovely to see so many people here wanting to talk Kubernetes at 8 o'clock on a Wednesday morning. That's always good to see. So whom I am, Chris Wraith. I am the engineering director at Elastic Path. Elastic Path, we build commerce solutions for customers. So we have a series of commerce APIs that really take the heavy lifting out of, putting together things online that you will use to sell things. It doesn't have to be a website, it can be a mobile app, it can be an embedded system, it doesn't really matter what it is. The point is it's API first, so you can, no matter what you're using to deliver your commerce solution, those APIs are there to help you, and they do the hard things like building your catalogs, building your carts, doing payments, handling checkout, all of that stuff. So we've been using Kubernetes for a long time, but previously, before that, I worked in financial services for places like NatWest and RBS. And again, we used Kubernetes there. But I also have a bit of a part-time hobby of in my spare time of doing lots of things with Raspberry Pis, and running Kubernetes on them is something that I've also done. So it's great fun. I can thoroughly recommend it as a learning experience, not for the faint of heart, but it's an excellent way to get introduced to the concepts that you need in a kind of low risk, low cost environment. So let's start talking about Kubernetes itself. What I'm going to do is I'm going to give you a little bit of the history of kind of how we got here. Why is it that we need something like Kubernetes? And then we'll talk about what it is, how it helps us, and I'll do a little bit of a demo to show you how to get started. It'll all be using tools that you can easily get access to. And hopefully it'll give you an idea of, to take some of the complexity out of it, because this is the thing with a lot of modern technologies that developers are using, things like Kubernetes. There's a lot of jargon in it, and I want to take some of that out and make it sound a little bit more straightforward. So I'll tell you a bit of a story. So kind of, we're not talking about the beginning of the universe here, we're just talking about the beginning of computing, but kind of we started off in a place where there were computers and there were programmers. And the programmers wrote the programs, they ran the programs, they had a computer to run them on, and everybody was happy. And then times moved on, and there were more programmers. There were teams of programmers even who wrote a lot, because there were so many programs that needed to be written. And one of the things that we found when we started working together in teams is that sharing computers with other teams could be quite hard. Teams get their computers set up in such a way that they have everything that team needs on it and nothing that other teams need on it. And so you get to the point where you have this sort of pet computer, and you maintain it the way that you want it. And then as companies started using more technology and they got bigger, there were more teams and more computers, and they got to the point where some of the members of these teams needed to try and organize the teams and the computers. And so some members of the team became, the idea of the CTO emerged, and they started talking to the finance leaders, and they started looking at the data centers and trying to understand what was going on. And they looked at these data centers full of lots of computers and all these servers, and they looked at the amount that they were spending on them, and they looked at the usage of these servers. And what they noticed was they were spending quite a lot of money, and the usage of the servers was quite low. CPU usage there at 4 or 5%, memory usage at 15%, and this was very strange. But of course, because all of the teams like to have their own computers, this was a situation that was going to come about. But thankfully, there were companies like VMware and Microsoft talked to lots of CTOs at the time who had exactly this problem, and they came up with a solution in the form of virtualization. What virtualization does is it takes your physical servers and it splits them up into virtual servers. So the CTOs and the finance folks are happy because you spend less money. Your physical servers are the things that cost you the money, and you slice them up into little virtual servers, so each of the teams still gets what feels like their own server. So they're happy, and that's all good. So that really helped us over a bit of a people situation there. But that only lasted a little while, because what we found then was that each of those virtual servers still became like the team's pet, still needed maintenance, still needed care and feeding. and it still got very accustomed to working with one specific team. So for example, if you've got a virtual server, if your team writes mostly Java code and you've got a virtual server that's set up to run a particular version of Java, that server's good at doing that. But if you come along and want to start running something different on there, maybe a different version of Java, or maybe a different platform altogether, you might not have the necessary things on there to do that, and that becomes difficult. So in an effort to try and commoditize the hardware on which people were running their programs, there's another great solution emerged in the sort of from about 2010 onwards, in the form of containers. And what containers allows you to do is it allows you to package up not just your application programs, but all of the dependencies that you need for them as well, all of the libraries, all of the SDKs, and pretty much everything else that's needed to execute this application. So it can really allow you to make the servers that this code is running on a genuine commodity. So it doesn't really matter where you run it. You have everything you need in this container, much like, you know, if you're the container analogy comes from shipping containers. You know, the ship knows that it can take 20,000 containers as long as they're the right size and nobody exceeds the weight limit. Everything's good. There's no problem. However, one of the other things that does happen is with containers is that we get to a point where we when we're running, because containers are designed to be run on any computer, there are things that can happen when you're deploying to a cluster of any computer that don't happen when you're just deploying to one machine. So things like the system administrator might decide that they just want to take that machine away and upgrade it for a bit, so that the machine that your code's running on might just go away. There are a whole complex scenario of network failures that can happen. And so what Kubernetes does really is it helps you manage those situations. So it's like I'm going to talk about it in the form of like an operating system for your cluster. More of that in a minute. So what you're seeing on the screen now is a sort of very small scale Kubernetes cluster. So this one's made up of 3 different nodes. When I say node, I just mean it's like a cloud virtual machine in this situation. So, you know, you can create those in, you can create an EC2 instance or a virtual machine in Google Cloud, and you can do the same in Azure. Each one of these is just a virtual machine. One is your master, or sometimes called the control plane, and that kind of manages the cluster. And the others are your worker nodes, which actually run your applications. You can have as many of each of these as you need, so you can scale this to very large numbers. I've heard of people using 1,000 or more node Kubernetes clusters, and so, you know, it's a highly scalable technology. As I said, it's an operating system for your cluster. What it really does, the real power of it for you as an application engineer, is that you get to define your application in containers, and you say what you need for your application. So what that means is you say, I need a certain amount of storage. Here's the configuration that I need to inject into my application. And here's what my app looks like when it's doing okay, when it's well. And that enables the cluster to make sure that your application gets the resources it needs, the right amount of CPU and memory, the right amount of storage. And it also lets the cluster kind of make efficient use of the number of nodes it's got. So if it knows how much memory a particular application needs and how much memory another application needs, it'll put those onto nodes that have enough memory and CPU and storage and all of the things that the app actually requires. It also will help you handle rollout and rollback, which, as I said, in network scenarios can be quite complicated. And it'll also be self-healing. So if you tell it what your app looks like when it's healthy, the cluster can actually help you recover it if it goes wrong. I'm going to just start seeding a couple of terms here. So what I'm trying to do is give you the analogy of Kubernetes as an operating system for your cluster. So there's some terms that Kubernetes use, and you might have heard them bandied around. I'm going to try and explain them in terms of concepts that you already know from existing operating systems. So in an operating system, when you run a program, that creates a process, and that process kind of has memory allocated to it. It uses a certain amount of CPU, and the operating system controls that and can manage that. In Kubernetes, the best analogy for that is called a pod. So that is where you define what your application is, you build it into your container, and when you run it, it becomes a pod. In operating systems, not so much in, there are operating systems that provide this as an abstraction, but a supervisor is something that gives you the ability to say, I want this program to be running all of the time. And if it's not running, I want you to check for it. And if it's not running, I want you to run it. So Kubernetes has something called a deployment, which does that. So the deployment itself will, you can say, I want this particular application to be running all the time. I want a certain number of copies of it. And Kubernetes will then manage the pods or the sort of operating system processes that exist underneath that to make sure your application is running all the time. You can configure your deployments using config maps and secrets, which are analogous to environment variables or configuration files in real operating system land. And cron jobs or jobs are things that you can create as well. So processes that are executed on a scheduled basis. So just wanted to get one concept over as well before we start with the demo, which is that when we're using Kubernetes, we want to be declarative and not rather than imperative. And what I mean by that is we want to say what the state of the system is that we want. We're not saying how to achieve it. So the example here is you're effectively saying to Kubernetes, I want 2 copies of my request logger application to be available at all times. You're not saying which hosts you want it to run on. You're not saying how you start those processes. You're just giving it the state that you want and letting it manage the cluster. So it's a slightly different mindset to what it is when you're writing a script, for example, where you have to say, I want this to happen first, then this to happen. And if this happens, do this. If this happens, do this. So these are the things that we're going to talk about today in the green. There's lots of other things in Kubernetes. I'm barely going to scratch the surface today because it's a big and complex area, but you know, this is a really good place to get started, and you can do the vast majority of things that you want to do as an application developer by getting to know the things that are in green on the left here. So deployments, pods, config maps, services, secrets, jobs, and cron jobs. So how do you create a cluster? Well, all of the major cloud providers have got offerings in this space. They're what you call managed Kubernetes offerings. So they will effectively build the cluster for you. They'll give you all of the things that it provides. You won't have to do any of the hard stuff that you do if you set up a cluster on bare metal or on Raspberry Pi for that matter. They will give you the ability to, for example, expose your services through network load balancers. They'll give you the ability to store data in persistent volumes. Those are all things that you don't get just out of the box with a bare metal installation. We'll talk a little bit more about this, and I'll show you some more examples in a moment. Okay, so I'm going to give you a bit of a demo. So firstly, I'm going to create a cluster. That'll take a couple of minutes in the background, so we'll start by doing that. And then I'll take you through my demo program, which I'm going to deploy into the cluster. I'm going to show you what it is and what it does. I'll show you how to run it locally, the old-fashioned way, as it were. Then we're going to build it and containerize it, and we're going to test it, and hopefully you can help with this. Then we're going to deploy it to Kubernetes, and we're going to poke around at it and see what we can do. Okay. So I'm just going to stop presentation for a second and jump out into, does anybody not see my browser at this point?
I can see it, Chris.
stuff. Okay, so I'm doing this in Google Cloud Platform. The only reason I'm doing it in Google Cloud Platform as opposed to anything else is because actually it's the quickest one to spin up, so it's quite helpful for demo purposes. So I've just got a Google Cloud Platform demo project here. So I'm going to go into Kubernetes engine here. I'm going to go into clusters. I'm going to create a cluster. Now there's two types of cluster you can create. You can create standard or autopilot. I'm going to create a standard one. Autopilot ones just are, those give you the ability to not have to deal with the nodes underneath them, but we'll not worry about that for now. I'm going to use the My First Cluster template on the right-hand side here. This is just the kind of lowest cost, most basic cluster you can set up. So I'm going to go create. So what this is going to do is it's going to create the machines underneath that are needed for the cluster, and then it's going to install all the Kubernetes stuff on it. So while that's happening, we'll come back to this in a minute. While the cluster is being created, I'm going to explain my demo program. Okay. So this is a demo program in Go. If you haven't seen Go before, don't worry, it's not very complicated, this program. It's literally just an HTTP server, which listens for HTTP requests. And then it does a few things here, which I'll explain. So the first, the entry point to any Go program is just the function main and the package main. So this is where we start. All I'm doing is creating an HTTP server, and I'm starting it. And every request for this HTTP server is going to be handled by this handle request function here. Now, what's going to happen is if the URI for the request, so the bit after the host name and the URL is /crashme, I'm actually going to exit this process completely. Now, I wouldn't ever recommend you do this, but it is useful for this demo, and you'll see why in a bit. The next thing that it does is it logs out what the URL what the URL path is. So you can see the requests coming in. And then I've just got this other bit here that says, if I've got this environment variable here, response value, if I've set that, then I want to echo out the response, which is actually the contents of that variable there. If not, I'm just going to echo out a response that says hello. So I'm just going to run this quickly now so you can see what it does. So I'm just running it locally on my machine here. I'm going to run curl against it, and you can just see here that this is a simple request. I get a simple response, and if you look at the log here, you can see there's there is a log entry that indicates that that request was received. Okay, so all straightforward enough, simple. The other thing that I'm going to demonstrate is if I use that crash me URL, I get no response, and it does actually crash the process. Okay, so there's nothing left now, it's stopped. So if we have a little look at this now, see if we've managed. We haven't quite got our cluster yet. So what we're going to do while that's happening, in order to deploy into the cluster, what I did there was I kind of ran the application just as a regular executable that ran on that's running on my laptop. So what I'm going to do is I'm going to containerize it so that we'll get it ready to deploy in the cluster. So to containerize it, we need this thing here called a Docker file. And the Docker file just says how to construct our container. So the first thing we do is we say it's from Alpine here. Now, Alpine is a minimal Linux image. It's got really nothing in it at all apart from the Linux kernel and a few very basic Linux tools. We then add our request logger program to it, and we put it in at this path, and then we say, I want to in order to run this container, this is the command that you need to run. So we can use a command called docker build to do this. So I'm going to build it. I'm going to call it Jackson PS4, which is just my Docker Hub account request logger. You'll see this notation a lot where you have a name and then a colon and then a version. So I'm just going to call it latest, and then I'm going to say my Docker file is in the current directory. So I'm going to do that. Okay. So we've got our Docker container there. So that is what we'll use in order to run our program. So what I realized is I didn't rebuild this. So I'm going to rebuild the program, just so you can see how to do that as well. So because it's running in a container, I need to say it's for Linux. Because this is one of these M1 Macs, I also need to tell it that because I'm going to deploy this into the cluster in Google, it's going to run on Intel hardware. So I need to say this is for Intel. I'm going to say I want to call it request logger, and I'm going to say that's the program I want to compile. I'm going to containerize again, and then I'm going to push that up to Docker Hub. And that just means once it's in Docker Hub, my cluster will be able to pull it down from there. Well, again, this is one of those things about the fact that you're running in a cluster. Deployment to the cluster, you needed some central place to pull all your applications from. So now my cluster is available. It's here. You can see it's we've got this nice green tick here. So to connect to it, I just click on these 3 dots here, click on connect. I get this nice command here that's going to link up my machine here, my terminal, to Google Cloud. So I've now done that. It's just a copy and paste exercise here. So we're going to try and talk to Kubernetes now. So I'm going to say, get me all the pods that are running. So kubectl or kubectl here is the command that you'll use to talk to Kubernetes and get all of the information that you need. Now, because I've just created this cluster, there are no pods there at all. What I'm going to do now is I'm going to deploy my app. So here is the deployment descriptor. Now this looks very complicated, but it's not. I can show you how to create one of these using the kubectl command. I'll do that in a minute. But the key thing about it is this is the Docker image I want to run. This is the thing I just built and just pushed up to Docker Hub. So I'm going to create a deployment that has this name, and this is the image that it's going to run. Okay, so I just need to apply that file to my cluster. That's my request logger deployment here. So the cluster's responded and said that my request logger has been created. If I go get pods here, I can see I've now got this pod, but I can't get to it. And the reason I can't get to it is because the pod isn't exposed anywhere. It's only visible inside the cluster. So what I need to do to make it visible, I need to create a service. So this is my service here. And this is going to point, it's going to give me an IP address that I can point to. And it's also going to point that IP address at this request logger app. So if I go ahead and create my service here, and I can get the services. You can see I've got my request logger service here. It's got an internal address in the cluster at this point, and it's just waiting for Google's Kubernetes engine to give it an external IP, which I'll just put a watcher on this so we can sit and wait while that happens. So what we've done so far is we have created an application and we've deployed it, and we've created a service which allows us to expose our application, and we're just waiting for Google to give us an IP address, which it's just done. So now if I go to that address, I'll be able to get my response there. And what I'm also going to do, if I can find the chat window, is I'm going to put that URL in the chat window. So feel free to hit this with any requests you like. What I'm going to do is put it, I'm going to get the pods here, and then I'm going to look at the logs for this. So you can see here that there's people firing some requests in here, which is good. you can also, and yeah, so somebody said hello there, nice, good. Okay, so what we've done is we've deployed this application now and we've got it running. But there's a few other things that I want to show you here. So I'm going to cancel this. One of the things that Kubernetes does, as I said, is it's self-healing. So if you look at that get pods request that I've just made, I can see I've got one instance of this pod, it's running, and there's 0 restarts here. I run my request to this URL and I put the crash me URL into it. See, I get my empty response from the server, but Kubernetes has restarted it for me. And you can see that because there's one restart there. And if I look at the logs, you'll see there that there's nothing in the logs anymore. All of that stuff that was in the logs before has got cleared out because that pod's dead now. So it knows that that the process needs to be running, and because it's not running, it's restarted it for me. So it helps you to, to deal with situations where the service has got into an unhealthy state. The other thing that might happen is you might get a lot of activity against this particular application. And so you need a bit more capacity to deal with it. And one of the ways that you can do that is by scaling it. So one of the things I can do here is I can say kube control scale deployment. And I can say replicas 8. What that's going to do, if I go back and get pods again, is it's going to create me 7 more replicas of my application. So I've now, instead of one pod handling all of my requests, I've got 8, and they could be running on different machines. So I've got a lot more capacity to deal with spikes in traffic or troughs in traffic. And then this gets really much more cost efficient for you when you start saying things like, instead of just trying to scale this manually, I can turn on something called auto scaling. So I could say kube control auto scale deployment, and what that'll do is that'll create me if I say max 10, what that'll do is that will create me a pod auto scaler, which will allow me to create more replicas in response to demand. So if I get loads of traffic to this host, to these applications, it will create me more pods in response. Another useful command to look at is something called kube control top. You can say kube control top pods. It's just like top in Linux. It'll show you which pods are using the most CPU and memory. So if you want to have a look and see, you can see this is pretty resource efficient, right? It's not doing very much, but 1 megabyte of memory and less than 1 millicore in CPU, which is 1,000th of one CPU. So that's pretty efficient as well. So that's most of the basic part of the demo. So while that's happening, I'm just going to go back to the slides and talk about some of it, just to kind of solidify some of these concepts here. So we talked about pods. Think of a pod like a process on Linux or Windows, and it's the thing that in this case, your cluster operating system, Kubernetes, is going to use to manage the resources that your program needs, like storage and configuration and memory. The thing about, because we're talking about a cluster operating system here, pod has an IP address because it's a network thing. It's not just a process ID, as it were. We also have the idea of a deployment, which is a supervised process. This is something that means that you can say how many instances of an application that you want to be running at a given time, and if one of them fails or disappears for whatever reason, if the node that's hosting it underneath goes away, the Kubernetes cluster knows, and it will create more instances of your application to make sure that the number that you've asked for is always there. I can give you a quick example of that actually. So if we go back to where we were, we have my, I'm just going to clear this. I'll go kube control get pods. You see I've got, I think, 8 instances there of that application, but if I just delete a couple of them randomly like that, and then when this comes back, I will get pods again, and those, you can see there's these 2 new ones here that are only 10 seconds old, so it's gone off and created them for me, because I've asked, when I set this up and I scaled it, I said I wanted 8 copies of it, but then I deleted 2 of them. But because I've got my deployment there, it knows, and so it says, you said you wanted 8, so I'm going to give you 8. Services are used to expose applications or to expose pods. So you just create a pod by itself, because they're ephemeral in nature. They can disappear and with no notice, because a node's been taken down or somebody's deleted a pod. If you were just talking directly to the pod, you wouldn't be able, there'd be a good chance that at some point that pod will go away. So what a service does is it sits on top of that, and it says, if you want to access this service that's hosted by one of these pods, here's the name that you can use to get to it. And that name will always be there. Unlike the pods that support it, which might change, they might move, they might go away. There are a couple of different types of service. So you can have a cluster IP, a node port, or a load balancer. So a cluster IP is for services that are internal to your cluster. So you've got one service that might talk to another service within the cluster, but no one needs to access it from outside. There is also a load balancer, which is the one that I used before to expose the request logger service to the internet. And what that does is it says to your cloud provider, please give me a load balancer that this service will accept traffic for. There's another one called an external name as well, which is if you just want to point a service internally at something that already has a DNS name. And what else have we got? We've also got these things called jobs or cron jobs, and these are there to allow you to run either, you can either run a command or an application once. So if it's a script that you just need to do some updates to something in your cluster, or if you need something to run on a regular basis, you can use a cron job for that. And it's pretty much the same as a cron job in Unix or Linux. The only difference is that instead of running a command on a host, you're telling it to run a container for you. And the great thing about containers is they can have anything in them. So anything you can imagine as an application, whether that's a shell script, it could be a Go application, it could be a Java application. You can run that as a cron job really easily inside a container. You always need to provide configuration data to your applications. So, we normally do this in the form of environment variables or configuration files, but in Kubernetes, because that needs to be shared between lots of nodes in a cluster, we use something called a config map. And it's just key value pairs. It's nothing more complicated than that. You can inject these key value pairs into your deployments. And that you can either do that as a file or as an environment variable. And that allows you to configure your application. You would normally use this for things like pointing it at the URL for your database or something like that. Possibly pointing it at a URL of another service you need to get data from. We also have secrets, which are pretty much the same as config maps, but you use them for things like usernames and passwords. The good thing about secrets is you can permission them separately in your cluster. So, you might want it set up so that anybody can read the config map data, but only the folks who manage the database system can access the username and password for the database. They're pretty much in most ways, secrets are the same as config maps. You can inject them as environment variables or files, but they're just permissioned differently usually. One other thing that's worth highlighting, the example that I gave you today where we crashed the server and it restarted was kind of an extreme example because if your application actually physically crashes, that's pretty bad. But what you can do is you can tell Kubernetes to say, here is an endpoint you can access, whether that's an HTTP endpoint or whether it's just a port that it needs to make a connection to. And you can say, if this endpoint is here and is returning a 200 OK status code, my application is good. And if it's not, my application is not healthy, and Kubernetes can feel free to kill the pod and restart it because it's obviously got itself into a bad state. This is also helpful for bringing applications into and out of service. So if you think about doing an upgrade to an application, what you often want to do is make sure that your new version of your application is up and is healthy before you bring your old application out of service. So when it comes to doing these upgrades, your users don't see any interruption in service. The term that's often bandied around is cattle, not pets. So that means that the idea is that if something isn't performing as expected, it's just destroyed and recreated from scratch, as opposed to treated as a pet that needs to be cared for and maintained. Now, there is so much other reading on this stuff. So the obvious places to start are the Kubernetes API docs. They're linked on this slide here, and they're a relatively, there's a lot in there, but there is everything that you need to know. I would recommend a couple of, there's lots of good introductory YouTube videos as well. But if you're interested in really getting to know the detail, there's a fantastic series called Kubernetes the Hard Way by Kelsey Hightower. He's also got some amazing YouTube videos that explain the concepts of Kubernetes from scratch. And he's a super speaker as well. So I would thoroughly recommend going through some of that stuff if you really want to get to know this a bit more. And that is it for the presentation side of things. So if you have any questions, now is the time. I've left the cluster running so we can try some things out. If anybody's got any questions that require any examples, we can go through and have a look at that.
Hi, Chris. My name is Brendan Mislari. I'm Associate Software Engineer in Sageza.
Hello.
So generally, as I understand, Kubernetes, it has almost the same concept as the cluster database, right?
It has the same concept as what, sorry?
Oh, I mean, it has almost the same concept in the way how it works as the cluster databases, where we had the master node, which is responsible for the child nodes of the databases in order to manage the traffic balancing and all that stuff, right?
Yeah, it does in the most straightforward setup. So you can have a Kubernetes cluster that has one master node or control plane and a number of other worker nodes that run your application. But you can also have a multi-master cluster, and most of the ones that are set up like this one that I've set up in GKE here, they have more than one master, more than one replica of the master configuration data. So, effectively taking out any single points of failure there for sure.
Okay, thank you very much.
Hi, Chris. I'm Diego. I just have a quick question about your example. In your example, where the Kubernetes server and this other service written in Go, where they're running different nodes.
Are they running different nodes? Well, that's a good question. So if I do kube control get pods and I put this wide option on, what you'll see is the node that they're actually running on. So you can see in this case, I've got 8 replicas here, and you can see they're all, I think there's 3 nodes in the cluster here by the look of it, and there's some replicas on all 3 of those nodes. If I go kube control get nodes like that, it shows you that there's 3 nodes in the cluster. So what happens is that when you deploy an application, it'll just, it'll pick nodes that have capacity usually. So that it's like I was saying before, if I go top, I can also do a kube control top nodes like this. So, you know, what it'll do is the cluster will look through at the requirements of the application. I haven't specified any here, but one of the things that you can do is you can say resources like this, and you can say CPU, I want 100 millicores, and memory, I need 100 megabytes of memory. And what that'll do is it'll tell Kubernetes what I need in terms of resources, and it'll always make sure that whichever nodes it puts it on will have enough capacity for it. The other thing that's worth mentioning is that obviously, in some cases, it might be desirable to make sure that you've got one copy of your application on each node, at least from a disaster recovery or high availability point of view, because that way, if one of the nodes is taken out of service for whatever reason, your users aren't going to notice any interruption in application service.
Okay, thank you very much. So we actually only create the master one, and then behind the scenes, all of these nodes or virtual machines are created, you know, friendly way?
Not really. So when you create the cluster has a certain number of nodes. So in this case, I've got a cluster that has 3 nodes in it, and it will always have 3 nodes for now, unless I actually go into my console over here and I say add another pool of nodes to it. I can have as many copies of the application as I want within that 3 nodes, as long as there is capacity for it. But unless I change the size of the cluster, it will always only have 3 nodes underneath it.
Okay, thank you.
Hey, Chris, this is Victor here from Bangalore, India. I just had one question where on a specific, the node, or not the node, the pod, if I want to add additional Linux binaries, how do I do that?
Yeah, that's a good question. So if you wanted to add additional Linux binaries to your pod, there's a couple of options, but generally speaking, the simplest way would be to build them into the container that you're deploying. So what I would do is I would put another add line into this Docker file here for my application, and I would make sure that whatever binaries I needed were in there. However, there are other options as well. So if you it depends on the application scenario that you're looking at. One thing you could do would be to use something called a sidecar in the pod. And what that does is it allows you to run another container to perform a specific task inside that pod. So you might want to, if you had a scenario where you're looking at, say, a system that pulls data from an upstream system and then does some processing on it, you could have a sidecar that pulls the data down, and then you could have a main application that processes that data and writes it to a database or something like that. So there's a lot of different ways to do it. I think the solution you choose really depends on the details of what you were trying to do.
Thank you.
There's a question a comment in the chat about wanting to do it on Raspberry Pi. It is doable on Raspberry Pi. and there's a lot of good guides out there for doing it now. The reason it's a good way to start is because obviously the only thing you pay for is the electricity and the cost of the device itself. You're not it's not like cloud costs, which are actually pretty low these days. But you know, the cost of running a full Kubernetes cluster permanently in something like GKE would probably be kind of $20 or $30 a month on the minimum specification. So you can do it quite cheaply if you use an autopilot cluster as well. But it's again, it's probably going to be cheaper to do it yourself, and it's also a good, useful learning exercise as well.
Hi, Chris. Johnny Farmer, Software Engineering Manager at Sky.
Johnny.
A question about observability with Kubernetes. So where, for example, it's auto-started a job, or where there's been issues with space, all those good things that we have our wonderful Kubernetes cluster, but when something goes wrong with that, we need to be alerted to it. So how do you go about implementing that?
Yeah, great question. Also, nice to see after.
Absolutely, and you too.
So observability is a really big field in Kubernetes. One of the things that when you've got a cluster itself, it's easy enough to observe the applications that are running within the cluster. But obviously, if something goes wrong with the cluster itself, that doesn't help. The way that other people tend to tackle this problem is they have a separate observability platform that is in another cluster or in another platform. So effectively, like something to supervise the thing that you really care about. There was a thing on the Google Kubernetes podcast recently about something called Ops Trace, which does something very similar to this. And they always recommend that you kind of deploy it in a cluster that's not your production cluster, because otherwise, how do you observe the observers as it goes?
Yes. Yeah. Okay. Thank you.
That's a good starting platform for learning Kubernetes, Raspberry Pi, microkits, or anything else. Right. Well, do you mean, let's see, starting platform? Well, I mean, Google Cloud's pretty good because you can, apart from anything else, if you've never signed up to it before, you get something like $300 of free credit. So it's not going to cost you anything really. And you can try it out for a good few months before it does start to cost you. So that's a really good place to start. But all of the cloud providers do similar things. So, you know, whichever one you are comfortable with is probably the best place to start with. For Raspberry Pi, obviously get one if you don't have one. They're relatively easy to order online. In terms of if you wanted to do Kubernetes on Raspberry Pi, it's much easier now than it was a few years ago. You're not having to recompile anything. You can all just, you know, apt-get install things that you actually need to run Kubernetes. It's pretty much as simple as making a few small configuration changes, then apt-get install kubadmin, and that will pretty much do it.
I've popped a link in the chat, Chris, which is to a selection of Pi clusters, including some that use the compute module.
Yeah, no,
because they're both great ways, and the Turing Pi is a good one to have a look at if you're looking at a different approach to clustering. And compared to online and keeping things always on, it's a very, very cheap way to test at home.
It's such a pity we're not in the shed, because nailed to the wall next to me in the shed, I have a 5-node Raspberry Pi Kubernetes cluster, which I could have just panned the camera around and showed you.
Joan, yes.
I was going to say it doesn't have the prettiness of this case that you've got on the screen here. It's pretty much plywood and nails, but
yeah,
super. If anybody has any more questions, then feel free. If you think of any afterwards that you desperately wanted to ask but didn't have the opportunity, you can get me on Meetup. I'm pretty easy to find on Twitter or LinkedIn or any of the other platforms. Also, by the way, did I mention we're hiring? So if anybody's interested in working for, doing some Go development, working in e-commerce, elasticpath.com has got details of the vacancies on there. So do hit me up if you're interested. Any other questions before?
No, thank you, Chris, and the organizers.
Okay, just remains to say thank you very much for having me. Like I say, I'm always happy to talk about anything Kubernetes or Raspberry Pi related. So feel free to hit me up if you've got anything that you like.
Cool. Thanks a lot, Chris. Can we just pop up the last kind of closing slides? I'll say a couple of words, and yeah, I think we'll be finished almost bang on time, which is great. Perfect. So yeah, obviously next event that's up next Wednesday, the 18th, another breakfast meeting. So Paul Hands, who's head of technology at DRS, will be speaking on workplace culture and COVID. I think everything, something that certainly affected us all in the last year and a half or so. So it'd be great to see you there. Just to kind of reiterate, if you've got any ideas for topics or would like to speak, do get in touch. My email address is there on the slide. Obviously, as we said, there'll be a recording of today's event on our YouTube channel, so that will go up shortly. So do check it out or pass it on to your network. Again, big thanks to Chris for speaking today. I'm sure you all enjoyed it, and thanks to Segeza for sponsoring the meetup. So yeah, I think all remains to be seen was thanks again. Thanks for joining us, and have a great Wednesday.
Yeah, thanks, Martin. Thanks, Chris.
Thank you.
Thank you.
Thank you.
Thanks all.
Take care now.
Cheers.
Thanks. Bye.
Cheers.